Very good. So, hello everyone, and welcome back to the second session of the 16th Avogadro meeting. So, the rules are the same as for the first session. So, each speaker will have 10 minutes plus questions, and the question will be done in the after the talk. Okay. So, the first speaker is Tommaso Macrelli, and he will talk about the double copy Lagrangians in Yang-Mills theory. Please, can you share the slides?
Yes. Can you see my slides?
Yes, we can.
Great.
Please go ahead.
Okay, thank you. So, thank you for the invitation. I am Tommaso Macrelli, and today I want to present you a work that I and my collaborators published this summer on a BRST-Lagrangian approach to double copy of Yang-Mills theory. There would be an upcoming paper coming out in January. So if you're interested, stay tuned. So to get started, the really naive idea behind the paradigm that sees gravity as the square root of a gauge theory can be summarized with this formula. Well, this is very heuristic since outside the identification of the fields, we see something like a tensor product of two gauge potential as a sum of a symmetric metric tensor, an antisymmetric field, and a dilaton that are the field of the physical field of a theory that we will refer to as n equals 0 supergravity. Aside the identification of the physical fields, these pictures say very few things on, it's very unclear. For example, where does it come from, the diffeomorphism invariance on the n equals 0 supergravity side? So the first concrete incarnation of this idea comes from string theory. In particular, it was obtained in the dualities between string theory scattering amplitudes, between open and closed string theory amplitudes. A purely field theoretic approach, a more modern approach, is obtained through the BCJ color kinematic duality and the double copy prescription. Now, just a flash review of these topics. Let's start with a general statement. Every Lagrangian field theory is equivalent to a theory with only cubic interactions. This can be said in generality thanks to homotopy algebra theorems, structural theorems that are valid for every Lagrangian field theory. But we can see this in a really concrete case, that is Yang-Mills theory. In Yang-Mills theory, we have a vertex with 4 gluons, and we can blow up this vertex into 3 contributions that goes in the interaction channel ST and U. In this way, we can organize a loop Yang-Mills amplitude as a sum of trivalent graphs. Now, in this formula, that is a loop Yang-Mills amplitude, the most important feature for us purposes is the numerator. We can split this numerator into 2 factors. The first factor is composed of gauge group structure constant, and we call it color factor. And the second factor is composed of contractions of polarization and momenta, and we call it kinematic factor. Now, there is some ambiguity in the choice of kinematic factor, and this is at the heart of the following statement, that is BCJ color kinematic duality. There is a choice in this formula of kinematic factor such that they obey the same algebraic relation of the corresponding color factor. For example, if the color factor satisfies Jacobi identity, then the kinematic factor will satisfy Jacobi identity too. This is proven to be true at 3 levels, but only conjectured loop level. And here's the conundrum. Since we can use the statement to do something really powerful, that is to compute gravity amplitude from Yang-Mills amplitude. And this is the Yang-Mills double copy prescription. So if BCJ duality holds true, so if the BCJ duality statement is true, then if we replace in this formula the color factor with a copy of the kinematic factor, what we obtain is a legitimate n equals 0 supergravity amplitude. Now, this is a no-loop statement. The problem is it relies on the validity of BCJ duality. So if we're in a straightforward way, we can think that to prove the validity of the double copy prescription, we have to prove BCJ duality for loops. But proving BCJ duality for loops is a really difficult task for various reasons. And we suggest a different approach. Until now, everything was an on-shell scattering amplitude story. We want to shift the perspective to an off-shell realization of this principle. What we want to do, the philosophy of what we want to do is the following. We want to double copy a Lagrangian equivalent to Yang-Mills theory and the associated BST operator, so really double copy the Lagrangian and the BST operator, and we will obtain a new theory that we have to prove that is a consistent theory. And then we have to prove that this theory is equivalent to n equals 0 supergravity. So let's start. The starting point is an existing reformulation of Yang-Mills theory. It was provided by Lagrangian obtained by Tolotti and Weinzel, and the problem is that it's a non-local Lagrangian. And the good thing is that it manifests tree-level BCJ duality. The non-locality is not a problem since we can make it local and strictify it to a Lagrangian with only cubic interaction, inserting auxiliary fields. Now, what we want to do is to double copy the complete BST extended field space. But the BCJ duality is satisfied only for on-shell physical gluons by construction. So in principle, we can have violation of BCJ duality coming from physical gluons and ghosts. So the approach is the following. We want to compensate this eventual BCJ violation with suitable field redefinitions. And we do this in a recursive way. So we start with the 4-gluon tree amplitude. So as I said, in principle, a physical gluon can ruin BCJ duality. And so we compensate this violation, this eventual violation, adding terms to the gauge fixing fermion and shifting in an appropriate way the Nakanishi outer field. And in this way, we compensated the eventual BCJ violation that come from physical gluons. Now, let's consider still a 4-point amplitude, but with a pair ghost-anti-ghost. Now, thanks to the word identity, we can relate an amplitude with k pairs of ghost-anti-ghost with an amplitude with k-1 pair ghost-anti-ghost. In this way, we redefine the ghost sector of the theory to compensate the eventual BCJ violation. And these are the first steps of a recursive construction. So for every tree amplitude with n external legs and k pair ghost-anti-ghost, we recursively redefine gauge fixing sector and ghost sector. And if we proceed in this way, what we obtain is a cubic action that manifests on-shell tree-level BCJ duality for the complete BST extended field space. Now, I have highlighted in 2 different colors, color structure and kinematic structure. And we can associate to this Lagrangian BST operator that has the following form. Now, we want to double copy. And we double copy both Lagrangian and BST operator, replacing the color structures and indices with a copy of kinematic structure and indices. So we obtain a new theory. Now, if the structure constant, the kinematic structure constant satisfy the same algebraic properties of the color structure constant, then we will have that the double copy BST operator square to 0 and the double copy action vanish under the action of the double copy BST operator. But we have that the double copy BST operator square to 0 only on shell. But that's enough, since it ensures that we have the correct word identity and a consistent quantization. Now, my time is almost finished, so next step would be to show that this double copy Lagrangian is related to n equals 0 supergravity by local field redefinition. this step is performed on the paper if you are curious. And in this way, we have obtained a double copy action that is perturbatively equivalent to n equals 0 supergravity. So we avoided the problem of proving BCJ duality for loops, and using this Lagrangian approach, we were able to say that this double copy action that we construct is quantum equivalent perturbatively to n equals 0 supergravity theory. Now, on the upcoming paper this January, there will be further detail about this construction, and also this construction will be reviewed in terms of homotopy algebras that are indeed a very natural language to study double copy. Using homotopy algebra tools, we can extend this approach to a zoology of theories. And for example, a next step would be to include in this picture supersymmetry. And so double copy a supersymmetric in this theory and obtain a supergravity with real supersymmetry. Next, the following task can be an homotopy description of open-closed string duality. And this is rather natural, since homotopy algebras are the natural language of string field theory. So that was everything I wanted to say. Thank you very much for your attention.
Very good. Thanks a lot, Tommaso, for the nice talk. Is there any question for Tommaso? So maybe I can ask one curiosity.
Sure.
I mean, you said that your goal is to try to prove this BCJ structure to all loops. So what is the status? So can you comment about that?
The status
in light of this?
In the short paper, we have concluded the proof for n equals 0 supergravity. So actually, this is proven for n equals 0 supergravity. And the various abstract steps that we discussed in the short paper would be expanded with also examples on the upcoming paper. Yes.
I see. So basically, once you get this, if you can get the same structure for the n equals 4 and you go to supersymmetry, then you will automatically prove.
There are some subtle issues with including in this picture fermions and then supersymmetry at the level of the homotopy algebras, yes, but they will be discussed in this.
And this n equals 0 double copy was proved before your paper, or your paper proved it for?
No, there were strong at 3 level, as I said, at 3 level was proven.
Yeah, but
at 2 level, there was strong hints of its validity,
but still
it was not proven.
People were not able to prove it.
Yeah, it was an open conjecture.
On-shell techniques. I see. And another curiosity I had, you mentioned in one of the first slides some statement about the fact that any theory with the suitable addition of auxiliary fields can be made cubic. I guess there are some assumptions in this statement. I mean, like you of course use it wherever there are a finite number of fields in a local theory. But is there any other? I mean, is it true?
It's a very general. Well, it's a very general statement, since it comes from a result that is called in the homotopy algebra literature as strictification theorem, that says that every homotopy algebra is equivalent to a strict homotopy algebra. That is a homotopy algebra with only the first 2 higher products. Now, under every Lagrangian field theory, thanks to the BV formalism, there exists an associated L-infinity algebra that grasps the complete classical theory. And this statement is actually valid for every theory that I can BV quantize. And yes, so even at the practical level,
even closed string theory, closed string theory. I mean, would you apply that? What I was wondering if there is any assumption here.
I'm more focused on field theories, but I don't know the answer for string theory. Possibly yes. But I don't. I should say that
if
I don't know.
This statement is general, then if there is no limitation on the number of fields that you have, in principle.
Yes. The point is that, for example, the number of the auxiliary field can be infinite. But the end, we have an action without a cubic interaction. Yes, practically this is obtained inserting auxiliary fields, yes.
Massimo, may I answer this question?
Yes, yes, of course.
Yeah, in the case of closed string field theory, actually for closed superstring field theory, there is this work by Ted Erlar, Konopka, Sachs, where actually they show that the formulation can be done in A infinity algebra. So there is a homotopy algebra, which is an A infinity algebra, which actually contains all the supersymmetric string field theory, for example. So this is the more updated version of the superstring field theory, for example. And indeed, it has an A infinity algebra instead of L infinity algebra. The L infinity algebra appear as the gauge symmetries of that theory. So the homotopy algebra in this case is A infinity, not L infinity. Yeah. For the bosonic ones, however, there is this work by Ohm and Gabardiel and other people where actually they shows that in this case it has L infinity algebra instead. Yeah.
I see. Okay. Thank you for the comments. Let's thank again Tommaso for the nice talk. And since it's time to move on, let's move to the talk of Giulia Peveri. Giulia, are you connected? Can you try to share the screen?
Yes.